In this video, we'll be solving the Pearson Edexcel IAL January paper of S1. So let's get into it. In question 1, it's about a histogram. We are given that the total is 408 plants. So total frequency is 408. We are given a partially filled table and a histogram, and using that histogram we have to complete the table. So from this bar over here, so 5 to 9, using the 5 to 9 bar we can find kf. So area equals to k times frequency. The area over here is, if we zoom in, so 1 2 3 4, so 4 boxes tall. 1 2 3 4 5 6 7 8 boxes across, or 9 minus, or you can just do 4. Consider 1 unit as 1 box. Now we'll get k times the frequency corresponding is 32. So the value of k will be 16 by 32, or half. So area equals to half times frequency. So using that we can find these values. So the area of the 15 to 17 bar would be 2 for 17 minus 15, and the height would be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So the area is 36. So 36 equals to half into frequency. So the frequency will be 36 by half, or 36 into 2, which would be 72. So this is 72. And for this bar over here, the height is 2. The area would be 2 into, it's from 25 to 17, so 25 minus 17 is 8. So 16 would be the area. So 16 equals to k times half times frequency. So frequency will be 16 by half, which would be 32. So this is 32. In part B, we have to use interpolation to estimate the median. So we know that the total number of term is 408. So the medianth term will be 204. So the 204th value would be the median. So if we write the cumulative frequency, this would be 32. The next one is 184. And the next one is 304. So we have got the median here. So the median is in this class. So median would be, if you don't know the formula, it's the lower boundary plus, then you will have the q-tooth term over here, and we subtract this, the cumulative frequency of the class before us, and then you divide with the frequency of the class we are in times the class width of that. So in this case, q2 will be, the lower boundary is 13, plus the q2 term we calculated is 204. The cumulative frequency of the group before is 184. This is 120, we've written thus, and the class width is 2. This is f and this is class width. So q2 would be 40 by 3. Okay. Now we have to describe the skewness. We are given the mean height, so we can note this down. If the mean is greater than the median, we say that it has a positive skew. If the mean is less than the median, we say that there is a negative skew. If they're similar, we say that the data set is positive. Data set is symmetric. So let's find 40 by 3 would be approximately 13.3. So the median 13.3 and the mean 13.2 are basically almost the same. So we can say that in question C, mean and median are almost the same. Most equal. So the data is symmetric. Now we say that two of these plans are chosen at random. We have to estimate that the probability that both of their heights are between 8 and 14 centimeters. So if it is what we had done before, we'll get how many? That's 72. Okay, so we are given 8 to 14. We know that 2 boxes are 1 unit, 10 boxes are 5, so 2 boxes would be 1. So 8 to 14, this is 9, this is 8. So this is 8. We'll have to consider this area. And up to 14, so this is 10, this is 12, this is 11, 12, 13, and this over here is 14. So the whole of this bar as well, and this portion of this bar. So this area over here will be from this is from 8 to 9, so 1 into 1 2 3 4. 4 is the area, so frequency will be double of that, so frequency will be 8 in this case. In this, the frequency we can directly find from the table, as the whole of the bar is in our range, so this will be 152, and for this part we'll have the height is 5, 10, 15, 20, 25, 30. So 30, and the width is 1. So this is 30, this is the area, so frequency will be twice of that, so 60. So the frequency we need is 60 plus 152 plus 8. So this comes out to be 220. So the probability we choose 2% consecutively from this, 2 plans consecutively from this would be, let me write this. P would be, the first time it would be 220 divided by 408, which is the total number of plans. However, we are not replacing the plants, so the number of plants will decrease on the second time. So this will be 219, and the total number of plants will decrease to 407. If we multiply this, we'll get 365 divided by 1258. So this is part D. So this is it for question 1. We'll be moving to question 2 now. This is a question about the product moment correlation. We are given the following statistics: the summation of x, the summation of x square, syy, sxy, and then we have to find the mean of the 12 values. So we can just go here. We are given n. We have to find the average minimum monthly temperature. So the monthly temperature is x. So this would be the mean of x, would be the summation of x by n, which is 862 by 12. We'll get the mean will be 71.83. Okay. Now we have to find the standard deviation of the 12 values. We have to show that it is 8.57, makes our work easier. So standard deviation of x will be root over summation of x square by n minus mean of x whole square. So this would be root over summation of x square is 62,802, n is 12, minus 862 by 12 whole square. So this will come out to be 8.5716, which is 8.57 to 3SF. So we have shown what they wanted us to show. Now in part B, we have to find the product moment correlation coefficient. The formula for this is R equals to Sxy by root over Sxx times Syy. So R here would be, you know that Sxy, we have to find Sxx. So let's just do it down there. Sxx would be summation of x square minus summation of x whole square by n. So this is 62802 minus 862 square by 12. We'll get 2645 by 3, or approximately 881.67. So the product moment correlation coefficient would be Sxy, which is 512.67 divided by root over Sxx, which is 2645 by 3 times Syy, which is 413.67. So this value will turn out to be 0.849. Now in part C we are given that they had to convert the temperature from Fahrenheit to degree Celsius. So C is degree Celsius and F is Fahrenheit. We have to use this formula, so this formula over here, and the values from part A to calculate the mean and the standard deviation in degree Celsius. So the equation for C is 5 by 9 F minus 32. 5 by 9 F minus 32. If we expand this, we'll get 5 by 9F minus 160 by 9. If we see mean of C, we'll get 5 by 9 times mean of F minus 160 by 9. So mean of F is basically the mean temperature. So 862 by 12. So this will come out 22.1. And as for the standard deviation of C will be, we'll start. The standard deviation of C will be 5 by 9 times the standard deviation of F. So standard deviation of C is 5 by 9 times the standard deviation of F, which was 8.57 over here. So 8.57 16. So this is equal to 4.76. That's it for C. Now in question D, we are given that U is the equivalent temperature in degree Celsius and V is the equivalent temperature of Y. V is for Y, U is for X. We have to find the product moment correlation coefficient for U and V. So this product moment correlation coefficient would be the same as this. So 0.849, and this is due to this being a linear coding. So as this is a linear coding, R is unaffected. With that, question 2 is done. Okay, so moving on to the next question, we are given this graph over here, this tree diagram, and we have to fill it. So in part A, we have to complete the tree diagram in terms of P when necessary. When do we need P? In this case. So if this probability is P, this and this will add out to be 1, because the total probability has to be 1. So if this was Q, P plus Q would be 1, so Q would be 1 minus P. So instead of Q, I'll just write 1 minus P over here, because we have to answer in terms of P when necessary. Same case over here. So 1 by 8 plus Q is 1, so Q will be 1 minus 1 by 8, 7 by 8. So this is 7 by 8. Now if this is 1 by 10, in the same way we can find this will be 9 by 10, because 1 by 10 plus 9 by 10 is 1. So this is basically how much of year 2 students are right-handed and left-handed, and how much year 3 students are right and left-handed. So we are given that the probability that a student is left-handed is 0.11. So how could a student be 0.11? He could be year 12 left-handed, or he could be year 13 left-handed. So what is the probability of year 12 and left-handed? It would be P times the probability of left-handed in this would be 1/8. So this, so P into 1/8. On the right, plus, not on the right, plus we have to find the probability of year 13 left-handed. So probability of year 13 is 1 minus P, and probability of them being left-handed is 1 by 10. So P by 8 plus 1 by 10 minus P by 10 equals to 0.11. So we'll get P by 40 over here, and on the right we'll get 0.01. So P would be 0.40. Now we are given, we have to find the probability that a student selected at random in year 12 and left-handed. So we have the conditions that the student is both in year 12 and left-handed. So basically we did this before, this probability over here. So P into 1 by 8, we know the value of P now, so this would be 0.40 into 1 by 8, which is 0.05 or 1 by 20. Now in part D, we are given that the student is right-handed. We have to find the probability that he is in year 12. So probability year 12 given that he is right-handed. So this formula will be the probability that he is in year 12 and he is right-handed divided by the total probability of him being right-handed, of picking a right-handed person. So if you do this, year 12 and right would be P times 7 by 8. So P is 0.4, so 0.4 into 7 by 8. In the denominator, we'll have the probability of them being right-handed. So if they're in year 12, so this will be 0.4 into 7 by 8. Plus, if they're in year 13 and right-handed, we'll have 0.6 times 9 by 10 into 9 by 10. So we'll get, and if we calculate this, we'll get 35 by 89. That's it for question 3. Now on to question 4, which is about correlation and regression. We are given that there are 11 students over here, and their marks in French and Spanish are given. Then we are given that this was plotted on a scatter diagram, and we have said that the point 30, 90 would be an outlier because 90 is an outlier for the Spanish marks. So we have to show that 90 is outlier. So we can see the range of values, wrong one, for Spanish is from 16 to 90. So 90 is on the higher end of it. So it should be in this. So we have to find Q3 at first. So Q3th term would be 3n by 4. So 3 into 11 by 4, which would be 8.25. So we need the ninth value. So the ninth value in ascending order of Spanish mark would be its upper quartile. So let's find this. The smallest is 16. This is 1. The next smallest would be 24. Then 28. Oh, it's given. So this would be the ninth. So 48 is Q3. So Q3 is 48. To find the interquartile range, we'd also need Q1. So Q1th term is 11 by 4, which would be 2.75. So the third value. The third value is 28. So 28 is the lower quartile. So Q1 is 28. Hence the interquartile range would be 48 minus 28 or 20. So the upper limit would be 48 plus 1.5 into 20, which would be 78. So we can say that as upper limit is 78, 90 is an outlier, or we can just write 90 is bigger than 78, so 90 is an outlier. Now we have summation of if, summation of s, SFF and SFS. We have to use this summary statistics to show that the regression equation would be this over here. So the value of for the regression equation, it's s in terms of f. So s equals to a plus bf. B will always be, in this case this will be s of fs by s of ff, because f is the dependent variable. B is usually, if you write the equation like y equals to a plus bx, the general form, the usual form, so B would be sxy by sxx. So if we change x and y into B and f, we'll get s fs by sff. So we can calculate B over here. B will be 1735.6, the value of s of fs, and divided by 1667.6. This would be 1.04. Now the value of A is y bar minus bx bar. So A would be here instead of y bar we'll have s bar and bf bar. So A will be summation of s by 11, which would be 382 by 11, minus the value of B. I'll write the exact one, 1735.6, 1667.6 times the mean of f, so 422 divided by 11. The value of A would be minus 5.72. Therefore S equals to minus 5.72 plus 1.04b shown. Now to part C, we have to give an interpretation of the gradient. So if the marks in French increases by 1, the marks in Spanish should increase by 1.04. This is what the gradient says. For every we can write this as the answer. Then we have to use the equation given above to estimate the Spanish mark for someone who scored 55 in their French test and someone who scored 18. So S equals to minus 5.72 plus 1.04f. For 1, F equals to 55, and for 2F equals to 18. So S will be minus 5.72 plus 1.04 into 55. We'll get 51.5 over here. For part 2, F is 18. So S will be minus 5.72 plus 1.04 into 18. This will be 13. Now in part E, we have to state with a reason which estimates of these two. So the ones we found in part D, which one of them is more reliable? If we see we use the values of the French mark being 18 and 55. The lowest marks in French was 24 and the highest was 68. So 55 is somewhere over here, but 18 is outside. So for 55, we'll use interpolation, whereas for 18, we have to use extrapolation. Interpolation is always more reliable than extrapolation. So we can say that the first estimate is an interpolation, whereas the second is an extrapolation. So the estimate in one is more reliable. That's it for question 4. Now in question 5, it's a question about normal distribution. We are given the mean is 40 meters and standard deviation is 4 meters. So if we write this, x is the distance an athlete can throw a discus, which is a normally distributed function with mean 40 and variance 4 square. Now we have to show in part A that the probability that this athlete can throw the discus less than 38.8 meter is 0.3821. So we have to find probability of x being less than 38.8. So if we convert it to z, probability of z less than 38.8 minus mean divided by the standard deviation, which is 4 over here. Keep in mind this is not 4 square. That would be wrong. The formula for converting probability x less than something would be probability z less than alpha minus mean by the standard deviation. This is the mean and this is the standard deviation squared or the variance. So we'll get probability z less than minus 0.3. If we visualize this on a normal distribution graph, this is 0, the median. Minus 0.3 will be somewhere over here, so minus 0.3. If we use symmetry, we can find that the area on the right of 0.3, so this red area over here and this blue area over here will be the same. So we can write this like probability z greater than 0.3. Now we can write this as 1 minus the probability z less than 0.3. So if we subtract the green area, if we subtract the green area from 1, we'll get the blue area. So we'll write this. We can just calculate this over here. We can find this using the table. We'll get 1 minus 0.6179 equals to 0.3821, and this is what we had to show. In part B, we are said that this athlete enters a discus competition. To qualify for the final, they have 3 attempts. And they have to throw it more than 38.8 meters. We have to show that given that they are qualified for the final and that the throws are independent, we have to find the probability that this athlete qualified for the final on their second throw with a distance of more than 44 meters. So we are given that he qualifies, so we have to find the probability of him qualifying at first. So probability qualifying would be him throwing this more than 38.8 meters at least once. We can do this in another way. We can write 1 minus the probability of x less than 0.3821 thrice. So not throwing less than 0.3821 3 times. Basically it means if we think about it, it is equivalent to it being thrown more than 38.8 meters once in 3 attempts. So we'll get 1 minus 0.3821 cube. So anything but throwing this discus less than 38.8 meters on all 3 of his attempts. Anything that's not this will ensure that the athlete is qualified. So this will be 0.9442. We have this information that once they qualify, they do not use one of the remaining so if athlete qualifies on their first attempt, they'll not throw it a second or third time. If they qualify on the second time, they won't throw it for a third time. And the probability we have to find is they qualified on their second throw, so they didn't qualify on their first throw, and they had a distance more than 44 meters. So we need to find the probability of x greater than 44. So this will be probability z greater than 44 minus 40 by 4. So probability is z greater than 1. It's like this. So it would be 1 minus probability z less than 1. If this is 1, this is the area we need. So it will be 1 minus the blue area. So 1 minus 0.8413, which is 0.1587. So the probability that we need is it qualifies on second throw with 44 meter plus throw, given that he qualifies. So this will be probability of 44 plus on second time intersection probability qualifies, so this will be the same thing, so divided by the probability of qualifying. This will be 0.1587 into you have to take into account that if he throws more than if he throws more than 38.8 meters on his first throw, he will not get a second throw. So we have to fail on the first try, so we'll multiply in 0.3821 over here. 0.3821. So we missed on the first attempt, we didn't qualify on the first attempt, and on the second attempt he qualifies, divided by the probability of him qualifying, which would be 0.9442. This is 0.0642. Now to question 6. We are given probability of A, probability of Y. They are variables X and Y. We are given that A union B is 0.65 and B given A is 0.3. And we have to show this equation forms of X and Y. So we are given probability of B given A. So this would be probability of A intersection B divided by probability of A. So this is also equal to 0.3 equal to, we don't know probability of A intersection B, and probability of A is X. So probability of A intersection B will be 0.3x. Now probability A union B will be probability of A plus probability of B, and then you subtract the intersection. So 0.65 equals to x plus y minus 0.3x. So 0.65 equals to 0.7x plus y. If we multiply both sides with 20, 0.65 into 20 is 13. 0.7x into 20 is 14. And 20 times 1 is 20. So we get this equation over here. We can rewrite it in this form as well. 14x plus 20y equals to 13. Now we are given that even another event B and C are mutually exclusive. So probability of B intersection C is 0. We are also given probability of C over here. So probability of B union C would be probability of B plus probability of C minus probability of B intersection C, but this is 0. So this whole thing over here is 0. So we can just erase this. Now probability of B union C is given 0.85. Probability of B is y. And probability of C is half x plus y. So we'll get 0.85 equals to half x plus 2y. So this is the equation. Now we have these two equations in form with x and y, so we can solve them simultaneously. From this equation and this. So if we take x as the subject on this equation, we'll get half x equals to 0.85. I think elimination method will be easier over here. So we have 14x plus 20y equals to 13, and half x plus 2y equals to 0.85. If we multiply this 10 times and then subtract it, we'll get 14 minus 0.5 into 10. So we'll have 9x plus 0y, 20y minus 2 into 10y, and 13 minus 10 into 0.85, so 13 minus 8.5, which is 4.5. So x is 2. Oh, so x is half. 4.5 by 9 is half. Now we can just put the value of x is in any of the equations. So 14 times 0.5 plus 20y is 13. 20y is 13 minus 7. So y is 7 by 20. Oh, 0.35. My bad, this would be 6 by 20. So 0.30. In part C, we have to show whether or not A and B are statistically independent. We can show that they are independent if probability of A times probability of B is equal to the probability of their intersection. So probability of, we'll find out probability of A times probability of B. Probability of A is X, so 0.5. Probability of B is 0.3 or Y. This will be 0.15. Now we need to find the probability of the intersection. The equation of the intersection, we found it over here. So this was 0.3x, so 0.3 into 0.5, so this is 0.15 as well. So we can make the conclusion that as probability of A times the probability of B is equal to the probability of A intersection B, A and B are independent. That's it with question 6. Moving on to the penultimate question. We are given a cumulative distribution function of a discrete random variable. So capital Fx. We have to show that k is 4 in part A. So we can say that k plus 4 by 8 is 1, because in a cumulative probability distribution, the total probability of this should always be 1. So we'll get k plus 4 is 8. So k would be 8 minus 4, which would be 4. Now on to part B. This was part A. We have to find the probability distribution function of this discrete random variable. So probability of x equals to x, x, and we'll have probability of x equals to x. The values are from 1 to 4, so 1, 2, 3 and 4. Probability of 1 would be 1 by 13. Now the probability of 2, probability x equals to 2, will be f of 2 minus f of 1. So which in this case would be 2k minus 1 by 26. So 2 into 4 minus 1 by 26 minus 1 by 13. To make our calculations easier, I'll find these out here. So we can just copy the values from the table. So 2 into 4 minus 1 by 26. This is 7 by 26. And this is 15 by 26. So we'll have 7 by 26 minus 1 by 30. We'll get 5 by 26 over here. Now for f, for p x equals to 3, we'll have f3 minus f2. We'll have 15 by 26 minus 7 by 26. We'll get 4 by 13. And now finally for probability x equals to 4, we'll have 1 minus, or f4 minus f3. So 1 minus 15 by 26. So we'll have 11 by 26. If we add these values up, we should get 1. It's always good to check this after solving it. And this does add up to 1. Now we have to use our answer to part B to find the model of, write down the model of x. So the highest probability of here is 4 by 13. If we write this with, in all of them with the fraction being in 26, we'll get 2 by 26, 5 by 26, 8 by 26, 11 by 26. This will be the mode because this has the highest probability over here. So mode equals to 4. Now we have to find the variance of 13 minus x. This will basically be 13 square variance of x. Now variance of x would be e to the power e of x square minus e of x whole square. If you remove the working of the last question from here, now let's bring this up. Okay. So using the table we can find e of x, which would be x times the probability of x equals to x. This is the actual formula. So it this term basically means the sum of the products of these things. So 1 into 1 by 13 plus 2 into 5 by 26, and we'll keep doing this. So we'll get 1 into 1 by 13 plus 2 into 5 by 26 plus 3 into 4 by 13 plus 4 into 11 by 26. This value will come out to be 40 by 13. Now for e to the power e of x square, this is basically the same thing, but instead of x we'll have the summation of x squared times the probability of x being x. So square of this times this plus the square of 2 times 5 by 26, just like the last time, but instead of 1 we'll have 1 square, instead of 2 square, squares over all of them. So this would be 1 square into 1 by 13 plus 2 square into 5 by 26 plus 3 square into 4 by 13 plus 4 square into 11 by 26, which would add up to be 135 by 13. So variance of x would be 135 by 13 minus 40 by 13 whole square. So variance of x would be 155 by 169. So variance of 13x minus 6 would be 13 square variance of x, or 13 square into 155 by 169. We'll get 155 over here. Now on to the last question of this paper. We have another question on normal distribution. We are given a random variable x in part A with mean mu and variance 36. So x is normally distributed, mean mu, variance 36. We can write it like this, 6 square. We are given this over here. So probability of mean minus 2k less than x and we have to find the value of k here. If we visualize this as a normal graph, this is the mean, this is the mean plus something, this is the mean minus the same thing. So this thing over here would be symmetric. My drawing doesn't look quite like that. Somewhere over here. This would be closer. And this would be mu plus 2k. So this distance and this distance are the same. Both of them are 2k. So the probability inside is 0.6. The probability over here and the probability over here should be the same because of the symmetry. So p plus 0.6 is 1. So p would be 1 minus 0.6 divided by 2. So this would be 0. So now we'll have probability mu plus 2k the probability of x being less than mu plus 2k to be 0.8 and the probability x less than mu minus 2k would be 0.2. So we convert them into z. So z less than mu plus 2k minus mu by 6 is 0.8. We don't even need this equation over here. So probability z less than 2k by 6, so k by 3 is 0.8. When the probability is 0.8, the value of z would be, we'll see the table, but instead of normally what we do is see the value over here and match it with the probability. Now in this case we'll see the value 0.8 and then try to find the probability closest to it. So k by 3 would be 0.8416. You can use the smaller table in this scenario because this is less than. If we switch the sign, we'll have 0.200. So you can use the smaller table over here as well. So we'll get k by 3 equals to 0.8416. So k is 3 times 0.8416 or 2.5248. Now we are given another distribution y with mean mu, standard deviation. Both of them are variables. We are given these equations over here, an equation connecting the mean to the standard deviation and the probability of it being greater than 3 by 2 mu. So probability y is 0.0668. So if we convert it into z, we'll get probability z greater 3 by 2 mu minus mu by 6 mu by sigma. Probability z greater than half mu by sigma. So now we know this relation over here. It's 2 mu equals to 3 sigma square. So 2 mu equals to 3 sigma square. Therefore mu is 3 by 2 sigma square. We can place it over here. So 3 sigma square. So one of these cancel out. So yeah. And if we convert this using the table, now we have to see the larger table. We don't have this on the smaller table. Oh, and we need to switch this sign as well. So probability z less than 3 by 2. Oh, this would be 3 by 2 itself divided by so this will be 3 by 4. So 3 by 4 sigma equals to 1 minus 0.0668. So 0.9332. Now you have to use the table for this value. See the probability. See when this probability happens for what value of x. For what value of z, my bad. So we'll have 3 sigma by 4, which would be 1.5. So sigma would be 1.5 into 4 by 3, which would be 2. So the mean would be 3 by 2 times 2 square, so 6. So y will be normally distributed 6 comma 2 square. That's it for this paper.